In the depths of dark space, 13.5 billion years ago, something happened that turned all the theories of scientists upside down. Gigantic galaxies came to life at a time when the universe was only 300 million years old. This was a situation that should not have happened. All the information we had was saying that galaxies could not form this early. But the James Webb Space Telescope would show us a different reality. Subscribing to our channel is a very important support for us. If you have subscribed, we can start taking a look at this reality. The galaxy called JADIS GSZ 140 was shining like a cosmic beacon in Webb sensors. This single point of light was carrying messages sent when the universe was only 300 million years old. To understand this, let us think like this. If we compressed the entire history of the universe into 1 year, this galaxy would have appeared on January 22. Scientists were expecting to find baby galaxies at this distance. Instead, they encountered an inexplicably matured, massive structure.
This galaxy contained millions of stars, and these stars had formed, completed their lives, and had lost their lives fast enough to create heavy elements like oxygen. Chemical measurements were showing concentrations that should have taken billions of years. George Reek from the University of Arizona describes the situation as truly mind-boggling. The galaxy must have started forming stars immediately when the Big Bang ended. There was no preparation period, no gradual accumulation. The stars had begun to ignite almost instantly. This galaxy contained millions of stars, and these stars had formed, completed their lives, and had lost their lives fast enough to create heavy elements like oxygen. Chemical measurements were showing concentrations that should have taken billions of years. George Reek from the University of Arizona describes the situation as truly mind-boggling. The galaxy must have started forming stars immediately when the Big Bang ended. There was no preparation period, no gradual accumulation. The stars had begun to ignite almost instantly. For this discovery, more than 200 hours of telescope time were required. When you extend your arm, a piece of the sky that appears smaller than a grain of sand was focused on. Every photon that reached Webb's mirrors had traveled for 13.4 billion years. These ancient light particles were carrying information about conditions that existed when the universe was only about 2% of its current age. Webb's infrared vision pierces through cosmic dust clouds that would blind other telescopes. The galaxy appears redshifted, its light stretched by the expanding universe during its incredible journey. By measuring this stretching, astronomers determine the distance and age with astonishing clarity.
What makes this discovery disturbing is the timeline problem. Current physics models predict that galaxy formation must follow a careful sequence. First, dark matter comes together under gravity. Then, normal matter falls into these invisible skeletons. Gas clouds slowly collapse and ignite the first stars. These stars must live their entire lives, explode as supernovae, and scatter heavy elements into space before second-generation stars form. This process, according to every computer simulation run so far, must take at least 1 billion years. Yet here, there is evidence that massive galaxies reached full maturity in less than a third of this time. The universe somehow appears to have skipped several critical steps in its own rulebook. The James Webb Telescope actually functions like a time machine. Looking into the depths of space means looking further back in time. This special galaxy represents the most distant confirmed object observed by human technology.
6 galaxies hang in Webb's field of view like cosmic criminals caught in the act. Astronomers have given them the nickname universe breakers because they violate the fundamental laws governing galactic formation. Each one has a mass more than 10 billion times that of our Sun, yet they existed when the universe was only 500 million years old.
Mike Boland-Colchin from the University of Texas is studying these galactic rebels with growing concern. According to every cosmological model created so far, these objects simply cannot exist. The standard cosmology model, called Lambda CDM, which has guided our understanding since the late 1990s, is being threatened by these 6 galaxies. They are putting decades of established science at risk of being overturned. The mass measurements appear indisputable. Spectroscopic analysis reveals that each galaxy contains stellar populations equivalent to 100 billion stars. It took our own Milky Way galaxy 13 billion years to accumulate a stellar mass of 60 billion stars. How did these ancient galaxies reach nearly twice that in 1/120th of the time? Computer simulations consistently show that early universe conditions prevented rapid galaxy formation. The dark matter halos, the invisible skeletons that hold galaxies together, required millions of years to grow large enough to capture significant amounts of normal matter. Additional time was needed for gas clouds to cool and collapse into star-forming regions. Yet these universe breakers appear to have ignored every constraint. They have converted nearly 100% of their available gas into stars. Modern galaxies typically achieve only 10% efficiency in this process. Such perfect conversion rates push against the theoretical limits of stellar physics. Astrophysicist Joel Leisure from Penn State describes the revelation as one that overturns established science. The research team informally calls these objects universe breakers, and they continue to deserve their name. Each new measurement confirms their impossible existence. The discovery originated from a multi-institutional project led by Stephen Finkelstein called the Cosmic Evolution Early Release Science Survey. The research examined a region of space roughly equivalent to looking at the moon through a straw. In this small sample, 6 massive galaxies appeared where none should have existed. This raises a disturbing statistical question. If such rare objects appear in every small piece of the early universe, how many more universe breakers are hiding beyond our current detection limits? The total number could reach millions across the entire observable cosmos. From this cosmic crisis, 3 possible explanations emerge. Either our understanding of dark matter evolution must be completely revised, or unknown physics governed star formation in the early universe, or the fundamental expansion rate of space itself was significantly different from current estimates. Each possibility requires large sections of cosmology textbooks to be rewritten.
Thousands of tiny deep red objects adorn James Webb's deepest images, like drops of blood scattered across a cosmic canvas. Astronomers call them little red dots, a nickname that barely captures their deep mystery. These miniature galaxies appeared less than 1.5 billion years after the Big Bang, shining with an inexplicable brightness. Dale Kachevsky from Colby College admits that scientists are astonished by this new population of objects. The little red dots challenge every assumption about early galaxy evolution. They measure smaller than typical galaxies, yet they overshadow objects 10 times larger than themselves. Their intense brightness indicates that something extraordinary is powering their cores. Each little red dot is approximately 1,000 light-years across, compact by galactic standards.
For comparison, our Milky Way stretches 100,000 light-years from one end to the other. Despite their small size, these objects emit more light than galaxies containing billions of stars. The red coloration provides important clues about their nature. Infrared observations reveal the characteristic wavelengths of hydrogen gas moving at enormous speeds. This signature indicates material orbiting supermassive black holes at speeds approaching 10% of the speed of light.
The black hole hypothesis creates its own set of problems. The growth of supermassive black holes from stellar mass seeds typically requires millions of years. They gradually accumulate matter by consuming nearby gas clouds and unlucky stars. The process follows predictable patterns observed in the modern universe. The little red dots appear to host fully mature black holes millions or billions of times heavier than the Sun when the universe was still in infancy. Current theories cannot explain how black holes grew this large, this fast in the early cosmos. Recent spectroscopic analysis confirms that many little red dots contain actively feeding black holes. The gas surrounding these objects shows clear signs of extreme heating and acceleration. Temperatures reach millions of degrees as matter spirals toward the event horizon. The feeding process releases enormous amounts of energy across all wavelengths of light. This radiation pressure should actually prevent additional matter from falling into the black hole, creating a natural limit on growth rates. Yet, these ancient black holes appear to violate this fundamental constraint. In the nearby universe, we observe nothing similar to little red dots. They represent a completely extinct class of cosmic objects that developed only in the earliest periods of the universe. Their disappearance raises questions about which catastrophic events ended their reign. The number of little red dots indicates that they were widespread features of the primordial cosmos. Nearly every deep field image from James Webb reveals dozens of these mysterious objects spread across vast distances. Their abundance implies that supermassive black holes played a dominant role in early galaxy formation. A team of astronomers from the University of Missouri stared at their computer screens in disbelief. 300 objects were shining with impossible brightness in James Webb's infrared images. These cosmic ghosts appeared where nothing should have existed, challenging fundamental assumptions about the early universe. Lead researcher Hao Jing Yan describes these mysterious objects as candidate galaxies from the infancy of the universe. The qualifier candidate reflects the team's uncertainty about what they have actually discovered. These objects shine far brighter than early galaxies should have been able to achieve.
The detection process resembled cosmic archaeology. Scientists applied sophisticated techniques, including infrared imaging, dropout analysis, and spectral energy distribution fitting. Each method confirmed the same impossible result: 300 objects that violate galactic evolution. Brightness measurements tell a disturbing story. These objects emit light equivalent to galaxies containing hundreds of billions of stars, yet they existed when the universe was only 5% of its current age. The timeline provides insufficient time for such large stellar populations to form and mature. Standard cosmology predicts that early galaxies should appear faint and small. The expansion of the universe stretches their light over billions of years of travel time. Ancient galaxies should be recorded as barely detectable whispers from the cosmic past. Instead, these 300 objects shout from space with astonishing intensity. The discovery required meticulous analysis of James Webb's early release observations. Astronomers examined every pixel of deep space images by searching for objects that disappear when imaged through specific filters. This dropout technique identifies extremely distant galaxies by their characteristic light signatures.
What emerged from this analysis defied all expectations. Instead of finding a handful of faint early galaxies, the team discovered 300 glowing signals. The statistical probability of such a discovery happening by chance approaches zero. There is something fundamentally wrong with our cosmic models. The objects span a range of distances and ages, but they all share the same impossible characteristic: extreme brightness for their era. Some appear to exist just 400 million years after the Big Bang. Others are dated to 700 million years after creation. All of them violate the predicted brightness limits for their respective periods. Co-author of the study, Bang Sun, emphasizes that spectroscopy will provide the ultimate test of the findings. This gold standard technique separates light into its component wavelengths, revealing precise information about distance, age, and composition. Only spectroscopic confirmation can determine whether these objects truly represent ancient galaxies. One object has already passed this critical test, confirming its status as an early galaxy. However, this single confirmation leaves 299 cosmic ghosts still awaiting analysis. The spectroscopic follow-up process will require months or even years of additional telescope time. At the cosmic center of the GN-Z11 galaxy, something impossible is hiding: a supermassive black hole 13.2 million times heavier than our Sun. The monster existed when the universe was only 800 million years old, far too early for such giants to exist. This discovery came from combining James Webb's infrared vision with the penetrating gaze of the Chandra X-ray Observatory.
The black hole, while devouring the surrounding matter, announces its existence through high-energy radiation. X-ray emissions provide undeniable evidence that the material heats up to millions of degrees before crossing the event horizon. Traditional black hole formation follows a predictable timeline. Massive stars exhaust their nuclear fuel and collapse into stellar mass black holes weighing 10 to 50 times the mass of the Sun. These seeds then slowly accumulate matter over millions of years, gradually transforming into supermassive monsters that anchor modern galaxies. The growth process faces natural speed limits imposed by physics. As matter spirals toward a black hole, friction heats the material with intense glowing radiation. This light creates outward pressure that opposes the black hole's gravitational pull. The result is a cosmic speed limit called the Eddington limit, which restricts how fast black holes can feed and grow. Even if early black holes somehow violated this limit and fed continuously at theoretical maximum rates, they still could not reach supermassive status in just 800 million years. The mathematics simply does not work within known physics. Yet here stands evidence that nature found a way around these fundamental constraints.
Roberto Maialino from the University of Cambridge led the team that confirmed the existence of this ancient black hole. Spectroscopic analysis revealed extremely dense gas moving at thousands of kilometers per second around the galactic core. These velocities require a gravitational field intense enough to be produced only by a supermassive black hole. The black hole's host galaxy, GM-Z11, had been surprising astronomers ever since it was discovered by the Hubble Space Telescope in 2016. The galaxy appeared unusually bright for its extreme distance and age. Webb's detailed observations finally revealed the source of this mysterious brightness: a supermassive black hole actively feeding from surrounding gas clouds. Oxygen atoms are floating in quantities that should not exist in the ancient Jadis GSZ 140 galaxy. This simple chemical element tells the story of impossible stellar evolution that occurred when the universe was only 300 million years old. The presence of oxygen this early in cosmic history violates fundamental rules about how elements form in space. Oxygen creation requires a complex stellar life cycle that should take hundreds of millions of years. Massive stars must first ignite, burn their nuclear fuel, and explode as supernovae. Only during these catastrophic explosions do stellar cores create oxygen atoms and scatter them into space. Second-generation stars then incorporate these heavy elements into their own formation processes.
The lead researcher, Jacob Hilton, who studies this ancient galaxy, describes finding significant amounts of oxygen as truly shocking. Measurements show that the galaxy potentially formed stars for 100 million years before Webb observed it. This pushes star formation to as early as 200 million years after the Big Bang itself. The timeline creates an impossible puzzle. If this galaxy contains significant amounts of oxygen, it must have already completed the evolution of multiple generations of stars. First-generation stars had to form, live out their entire lives, and explode. Then, second-generation stars had to form from the enriched gas clouds left behind by these explosions. The universe is expanding, but scientists cannot agree on how fast it is expanding. Two different measurement methods, despite decades of increasingly precise observations, produce conflicting results that refuse to reconcile. James Webb's latest data has made this cosmic crisis even worse, confirming that something is fundamentally wrong with our understanding of reality. Nobel Prize-winning astronomer Adam Rees measures the expansion rate using nearby stars called Cepheid variables. These stellar beacons pulsate with predictable rhythms that reveal their intrinsic brightness. By comparing this true brightness with the observed faintness, astronomers calculate precise distances across cosmic space.
This method gives an expansion rate of 74 kilometers per second per megaparsec. The measurement means that space stretches by 74 kilometers every second for every 3.3 million light-years of distance. This cosmic stretching pushes galaxies apart at accelerating speeds across the observable universe. The second method examines the cosmic microwave background, the leftover radiation from the Big Bang itself. The European Space Agency's Planck satellite mapped this ancient light with extraordinary precision, revealing small temperature fluctuations that encode information about the fundamental properties of the universe. These primordial measurements predict an expansion rate of only 67 kilometers per second per megaparsec. A difference of 7 units may seem small, but it represents a deep disagreement about the nature of cosmic evolution. The inconsistency exceeds all known sources of measurement error. Another Nobel laureate, David Gross, describes the situation as a crisis rather than a tension or a problem. The disagreement has persisted for over a decade, despite continual improvements in observational techniques. Both measurement methods have been checked, cross-checked, and validated by independent research teams. James Webb's involvement was supposed to resolve this cosmic mystery. The telescope's infrared sensitivity allows observations of Cepheid variables in galaxies 130 million light-years away. These distant measurements should clarify whether systematic errors affect closer observations.
Instead, Webb confirmed the higher expansion rate with even greater precision.
A recent study observed 1,000 additional Cepheid stars in 5 host galaxies and strengthened confidence in the local measurement. The data rule out measurement error as the cause of the Hubble tension with very high confidence. In the early universe, stellar nurseries were operating at impossible speeds. The collapse of gas clouds into stars, which should have taken hundreds of millions of years, completed this process in cosmic blinks of an eye. James Webb reveals galaxies containing billions of stars that formed when the universe barely had time to cool down from the initial heat of the Big Bang. Modern star formation follows predictable patterns that astronomers have studied for decades. Gravity slowly compresses giant molecular clouds until their cores reach 10 million degrees. Nuclear fusion then ignites, converting hydrogen into helium and releasing the energy that makes stars shine. This process typically requires 50 to 100 million years from initial collapse to stellar ignition. The early universe should have made star formation even more difficult. Higher temperatures and densities created turbulent conditions that resisted gravitational collapse. The absence of heavy elements meant that gas clouds lacked the cooling mechanisms that facilitate modern star birth. These factors should have slowed star formation to glacial speeds. Yet, Webb observes galaxies containing stellar populations that formed almost instantly in cosmic terms. These ancient galaxies reached star formation rates thousands of times higher than the most active regions in today's universe. They converted nearly 100% of their available gas into stars, far exceeding the 10% efficiency of contemporary stellar nurseries. In the oldest galaxies, microscopic dust grains float, carrying impossible histories written in their crystal structures. These microscopic particles should not exist this early in cosmic time. Yet James Webb detects their undeniable signatures throughout the primordial universe. Their existence demands explanations that current astrophysics cannot provide. Cosmic dust forms in the atmospheres of dying stars during their final evolutionary stages. Red giant stars shed layers of gas enriched with heavy elements forged in their nuclear cores. As this material cools in the vacuum of space, it condenses into solid particles composed of silicates, carbon compounds, and metallic crystals. The dust formation process requires specific conditions that should not exist in the early universe. Stars need sufficient time to evolve through their full life cycles, consume their hydrogen fuel, and transition into helium-burning phases. Only massive stars can progress through these stages fast enough to produce dust within a few 100 million years. Yet Webb observes dust signatures in galaxies that existed when the universe was only 500 million years old. These ancient dust grains appear indistinguishable from particles found in modern galaxies, showing that similar formation mechanisms have operated throughout cosmic history. At cosmic dawn, James Webb discovered sleeping giants where none should exist. These dormant galaxies contain billions of stars, but show no signs of active star formation. Even though the universe is younger than 1 billion years, their peaceful slumber challenges every model of early galactic evolution. Astronomers call them sleeping beauty galaxies, massive structures that exhausted their gas supplies billions of years ago and entered cosmic hibernation. In the modern universe, such dormant systems are commonly found among elliptical galaxies. Finding them in the early cosmos shows us a fundamental violation of cosmic evolution timelines. The discovery emerged from Webb's deepest observations of ancient cosmic neighborhoods. Spectroscopic analysis reveals galaxies containing stellar populations with ages approaching 1 billion years. Yet these systems show no current star formation activity. Their gas supplies appear either exhausted or somehow prevented from collapsing into new stellar nurseries.
Kate Whitaker from the University of Massachusetts is leading research into these enigmatic dormant systems. Her team identified 12 quiescent galaxies in regions where active star formation should dominate cosmic activity. These objects appear remarkably mature while the universe itself is still in its infancy. The timing problem challenges fundamental assumptions about galaxy life cycle evolution. Current models predict that early galaxies should continue actively forming stars for several billion years after their initial ignition. Gas supplies should be abundant, and feedback mechanisms should be insufficient to completely halt star formation. Yet these dormant galaxies, within a few 100 million years after their birth, somehow transitioned from active star formation to complete quiescence. They reached mature status faster than physics should allow, then, despite having access to cosmic gas reservoirs, suddenly shut down all star production. In the ancient cosmos, an impossible collision unfolds in James Webb's infrared vision. 5 separate galaxies spiral toward mutual destruction that may occur perhaps only once in the entire observable universe. This extraordinarily rare fusion system, nicknamed the Quintet, violates the statistical laws governing galactic encounters.
Wider, from Texas A&M University, is leading the team studying this unprecedented cosmic catastrophe. Even the probability of detecting a single fusion involving 5 galaxies using current cosmological models approaches nearly zero. That Webb found such a system this early in its observations suggests either extraordinary luck or a fundamentally flawed understanding of early universe conditions. The fusion system exists as observed about 800 million years after the Big Bang, during a time when galaxies were packed more densely, yet still separated by millions of light years of space. Arranging a 5-way collision requires extremely precise alignment of orbits across vast cosmic distances. The gravitational choreography stretches the imagination. Each participating galaxy contains billions of stars that will eventually be scattered into intergalactic space as their parent systems are torn apart. The collision generates shock waves that compress gas clouds and trigger explosive episodes of star formation. At the edge of detectability, James Webb has identified mysterious objects that challenge the nature of reality. These rogue entities appear to roam freely through intergalactic space, independent of the gravitational influence of any parent galaxy. Their existence violates the fundamental principles of cosmic structure formation. Yet computer simulations suggest they may be ghostly mirages rather than physical objects. These appear as isolated point sources of infrared light spread across Webb's deepest observations. Although they exist billions of light years away from Earth, they lack the typical extended structure of galaxies, instead resembling individual stars more closely. Their solitary nature defies explanation through conventional astrophysics. The initial discoveries generated tremendous excitement among astronomers searching for new classes of cosmic phenomena. Free-floating planets ejected from their parent star systems could explain some observations. Alternatively, primordial black holes formed in the earliest moments of the universe could masquerade as isolated point sources. However, detailed computer simulations raise doubt about the physical reality of these rogues. Theoretical models suggest that instrumental structures or data processing errors could create visible objects where nothing actually exists. The mysterious sources may represent digital ghosts trailing Webb's sophisticated imaging systems. A cosmic traveler carries impossible secrets through the void between the stars. The third interstellar visitor, Comet 3I Atlas, the third ever detected in our solar system, harbors a dark truth that challenges everything astronomers understand about planetary system formation. James Webb's analysis reveals that this ancient traveler may be 7 billion years old, making it 3 billion years older than our entire solar system.
The comet originated from the Milky Way's thick disk, a stellar population dated to the galaxy's violent youth. Unlike our Sun, which formed in the galaxy's thinner disk composed of younger stars, the thick disk represents an ancient stellar graveyard carrying memories of primordial chaos, populated by cosmic veterans drifting through space. NASA's James Webb Space Telescope aimed its infrared instruments at the interstellar intruder during its passage through our cosmic neighborhood. Detailed spectroscopic analysis revealed chemical signatures telling a story of cosmic wandering across unimaginable ages and impossible distances. Orbital calculations paint a picture of an epic cosmic exile. This comet drifted through the empty spaces between stars for billions of years, surviving encounters with stellar radiation, cosmic rays, and gravitational disturbances that should have destroyed such a fragile object countless times. In the primordial universe, galaxies clustered together like cosmic grapes hanging from invisible dark matter vines. This strange phenomenon challenges every model of early galactic formation, creating dense concentrations of massive systems where none should exist. The clustering appears organized according to unknown principles operating beyond the limits of gravitational physics. The grape-like structures contain small dark matter halos, each merging to form larger structures that eventually capture enough normal matter to ignite star formation. For the process to create massive galaxy clusters requires billions of years. Yet, Webb observes fully formed cosmic grapes when the universe was only 800 million years old. These ancient clusters contain galaxies with stellar populations approaching several billion years in age. The timeline provides insufficient time for traditional cluster assembly mechanisms to operate. The discovery emerged from one of Webb's deepest surveys of distant cosmic neighborhoods. Astronomers mapping the three-dimensional distribution of early galaxies found unexpected patterns resembling biological structures rather than gravitational systems. The resemblance to grape clusters gave the phenomenon its unforgettable nickname. Each cosmic grape contains between 10 and 50 individual galaxies compressed into volumes smaller than modern galaxy groups. The dense packing creates gravitational interactions that should rapidly destroy the cluster through dynamical heating effects. Yet, these ancient structures preserve their integrity across cosmic time. A planet orbits a dead star while cosmically defying every law of atmospheric survival. This impossible world, identified with clinical precision by astronomers, retains an atmosphere composed entirely of carbon monoxide and carbon dioxide, while orbiting a white dwarf remnant that should have consumed any existing gas billions of years ago. The discovery shattered fundamental assumptions about planetary evolution around stellar corpses. When stars, like our Sun, exhaust their nuclear fuel, they expand into red giants that swallow nearby planets before collapsing into white dwarf remnants. Any surviving world should be an airless rock stripped by the stellar death process. Yet James Webb's spectroscopic analysis reveals a world that somehow preserved its atmospheric envelope through cosmic catastrophe.
The planet's carbon-rich air represents the first confirmed atmosphere detected around a white dwarf system, opening entirely new chapters in planetary science. The survival mechanism challenges conventional physics models. During the red giant phase, stellar winds reaching thousands of kilometers per hour should have stripped away any atmospheric gas within millions of kilometers of the dying star. Radiation pressure alone exceeds the gravitational binding energy of most planetary atmospheres. Across 8 light-years of empty space, twin superheated plasma jets erupting from a monstrous star flow like the tentacles of a cosmic jellyfish stretching into the void. This stellar outburst creates one of the largest coherent structures ever observed emerging from a single astronomical object, extending twice the distance between our Sun and its nearest stellar neighbor.
The phenomenon originates from a star with more than 100 times the mass of our Sun, undergoing violent evolutionary processes that current stellar physics cannot adequately explain. The object represents a volcanically growing monster, ejecting material at speeds approaching 10% of the speed of light. James Webb's infrared instruments capture the full extent of these stellar tentacles for the first time, revealing complex structures that suggest intricate magnetic field interactions operating on scales never before observed within plasma jets. At the center of our Milky Way galaxy, the 4 million solar mass black hole known as Sagittarius A erupts in random flares that astonish astronomers studying its behavior. James Webb's unprecedented observations reveal that our galaxy's central engine operates in chaotic patterns that invalidate every model of supermassive black hole activity. The monitoring campaign required 48 hours of continuous observation spread across 8 separate sessions, each lasting up to 10 hours. This intensive effort represents the most detailed analysis ever conducted of our galaxy's central black hole, using infrared instruments sensitive enough to penetrate the obscuring dust clouds veiling the galactic center.
Professor Farhad Yousafzadeh from Northwestern University leads the research team studying these irregular flaring patterns. The observations reveal a constantly varying swelling brightness, punctuated by sudden explosive bursts that appear completely random. After months of detailed analysis, no mathematical pattern emerges. James Webb looks 13.5 billion years into the past, approaching the theoretical limits of observational physics. Yet the telescope's most distant detections seem to violate the fundamental constraints that should govern how far back in time any instrument can see. These observations approach the cosmic horizon where space and time themselves began. The paradox arises from Webb's ability to detect fully formed galaxies at redshifts approaching infinity. The light from these ancient systems traveled for nearly the entire age of the universe, carrying information from cosmic conditions that should have completely prevented galaxy formation. Every prediction made by Lambda CDM lies in ruins around James Webb's observations. The Lambda CDM framework, which has guided astronomical research for 30 years, cannot explain the telescope's most fundamental discoveries. Galaxies appear where none should exist, black holes grow faster than physics allows, and the universe expands at rates that violate theoretical constraints.
The cosmological crisis began with Webb's first scientific observations and deepened with every subsequent data release. Galaxy formation timelines turned out to be completely wrong. Star formation rates exceeded theoretical limits. Chemical evolution progressed faster than nuclear physics allows. Each discovery destroyed another pillar supporting modern cosmological theory. The laws governing cosmic evolution are laws that terrestrial science has never encountered. James Webb's observations demand fundamental forces, exotic particles, and alternative physical principles that exist nowhere in terrestrial laboratories or theoretical frameworks. The universe reveals itself as an alien structure governed by mechanisms beyond earthly understanding. Theoretical physicists are rushing to invent new mathematics capable of describing Webb's impossible observations. The required changes span every branch of physics, from quantum mechanics to general relativity. No existing theory survives contact with observational reality. The laws of physics themselves seem to change over cosmic time, turning James Webb's observations into evidence of a fundamental instability of reality. The strength of gravity, the speed of light, and the masses of fundamental particles may fluctuate according to unknown principles that render the universe inherently unstable.
At the smallest scales of space and time, reality dissolves into a boiling quantum foam where virtual particles exist and vanish before completing their brief dances of creation. James Webb's observations suggest that this microscopic chaos may govern cosmic evolution at the largest scales, presenting the universe as a fundamentally unstable structure balanced on the edge of non-existence. Across billions of light years, dark matter filaments weave a cosmic web that binds every galaxy together in patterns too organized to arise from random gravitational forces. James Webb reveals that this larger structure in the universe appears to be designed according to principles that imply an intelligence operating at scales that dwarf human comprehension. Every assumption collapses under the weight of James Webb's revelations. The universe does not follow rules intelligible to earthly intelligence. We live in a cosmos containing galaxies that violate causality, black holes that defy physics, matter that organizes itself through unknown intelligence, time flowing backward, space existing in quantum superposition, and reality that changes based on observation.
In the darkness between the stars, questions multiply like a cosmic cancer, devouring every assumption humanity has made about existence. James Webb opened doors that can never be closed by revealing mysteries that will torment human consciousness until the last star burns out and the universe itself dissolves into quantum foam. Which intelligence designed the perfect geometry of the cosmic web? Why do fundamental constants change throughout cosmic time? How do galaxies form before the universe allows their existence? Which forces violate causality itself? These questions find no answers within human conceptual frameworks. The deepest question, however, arises from realizing that Webb's discoveries represent not a solution, but the beginning of cosmic mystery. Every observation presents us with new impossibilities that multiply the total number of unanswerable questions. What we know as knowledge becomes ignorance. Discovery becomes confusion. Progress becomes a retreat into cosmic mystery. In the end, we're left with questions that will follow human consciousness until consciousness itself dissolves back into the quantum foam from which it emerged. The universe holds answers that no earthly intelligence will ever be capable of understanding, but we will still continue to measure, to observe, to follow the path of science. Remember that unless one of us advances, none of us can advance. Good night.